back. So our coefficient of determination, which is known as R squared, is SSR divided by SST. But SST is this value right here. So that's going to be 2, 5, 6, 8, 1.6. And SSR we have to calculate. So let's calculate SSR. So one more equation we got here. Go back to your formula sheet. Here's SSR. Again, don't use the first one because that's going to be too much work. We're going to use this one because we already have these values. Is XY squared divided by SXX. So we're going to write that one down. All right, so plug in your X, Y value, which was negative 862.2 squared. And then our XX value was 30.9, and let's calculate that.
I got a very large number. I don't know anyone else.
Did you get 0.93? You didn't get 0.3?
No.
Oh, for the, yes, I'm sorry. I didn't all the way to the end. I apologize. Yes, SSR is a large number. SSR came out to 24,057.
Yes, okay.
Yeah. Sorry, I went ahead and just started calculating everything and I was like, wait a minute. Yeah, 24,057. So that's what's going to go on top. So here's how you know you're on the right track. Let me point that out right now. R squared is going to be a percent. It's going to be between 0 and 1. If your R squared is not coming out between 0 and 1, you definitely did something wrong somewhere. Does that make sense?
Yes.
Good. It's a kind of a way you can check yourself. And quite honestly, here's the other thing. If you have a scatter plot, and you're not always going to have a scatter plot. We did a very rough scatter plot when we started this problem. And you can see even our rough scatter plot shows, see how closely scattered around that line those points are? Because the points are so near the line, we should expect a coefficient of determination that's almost equal to 1. If our graph looked more like this, do you see what I mean?
Yeah.
Do you see how they're not scattered very much around the line? That would lead us to a coefficient of determination that is much smaller, like closer to 0.
Okay.
So that's kind of what the coefficient in a visual sense, the coefficient of determination tells you is how kind of snug around that line are your points. So as you can see, if we now finish this problem, whoops, keep putting stuff on there. So when we finish it, we take our SSR. Remember, SST you don't have to calculate. That just equals, I know there's so many different things, but if you just practice a few problems and you really get to learn that formula sheet, I think it'll all start to kind of fall into place. I got 0.93 when I did this. So I don't know if anybody else got point. But I'm also sneaking into the back of the book and making sure that that is the correct answer. Real quick.
0.9. I got 0.966. So.
Okay, so yeah, 0.936 would be, and then what was the next number? 7. So yeah, it would be about 94%, we could say. I think that would make sense, about 94%. So let me just double check. Yeah, I can't find the answer, so we're just going with it. I believe that is correct. Because our SSR was 24,000. Yep, nope, that is correct. And that makes sense based on what we saw in the beginning. So once you kind of start to understand, and like I said in the video, I'll explain the coefficient determination a little bit better, but once you start to understand these numbers, you know, this number should very much be related as you're going through, especially some of the math labs where they have you, where they put up those scatter plots. And, you know, this is also should be problems that you should be opening as you're going through math lab into StatCrunch, because then you can see the scatter plot yourself. And that number should very much reflect the scatter plot of points really close to the regression line. So that means 94% of our variation can be explained by a regression line. So we got a really good regression line. The last part, when it comes to this, that we would continue with one problem is actually 14.4, because 14.3 is all about coefficient of determination. And 14.4 is the correlation coefficient. Just can't seem to spell this morning. Okay, it's very much related to the coefficient of determination. In fact, you can almost tell right away. Coefficient of determination is R squared. Correlation coefficient is simply R. They are that much related. One is the square of the other, with a slight variation, and we'll go over that in 1 second. You've heard correlation before. How well are two variables correlated with each other? And you've heard all sorts of crazy stories like correlation does not mean causation. I'm sure you've heard that before. A typical example I always give is, you know, one year a statistician decided to do some research. This is like back in the early 80s, late 70s in New York City, and showed there was a super strong correlation between ice cream sales and murders in New York City. Okay, does that mean that eating ice cream makes somebody want to go out and commit murder? Absolutely not. But they're highly correlated because there's other factors that make them correlated, right? Like it's hot out. People don't want to go outside and eat ice cream in the winter. And I guess people who are inclined to commit crime don't do it in the winter. So that's the idea of correlation. But here's the difference. Correlation needs to also include whether two variables are positively correlated or negatively correlated. So correlation will also be between 0 and 1, but it'll be either positive or negative. Looking at our regression line and looking at our scatter plot, do you think this set of data is going to have a positive correlation or a negative correlation? You want to take a guess?
Would it be a negative correlation?
Yes.
Okay.
And with absolutely. And number one, it's going to pertain directly to the slope. If the slope is negative, you got a negative correlation. If your graph is going down, you have a negative correlation. Okay. And what that means is as the cars age, as the Corvette ages, what's happening to the price? It's decreasing. So it's definitely a negative correlation. But we need to know how strong that correlation is. And since we had a pretty high coefficient of determination, we're probably going to have a pretty strong correlation coefficient as well. So let's look at the formula sheet. Now, what most students will do is the absolute quickest way. Notice there's a lot of formulas for R. Do you see them all? All right, I would ignore this one. That is just crazy. That's the defining formula. We're not going to use that. This one is way simpler, right? But there's also another thing, but we've got to be careful with this one. Obviously, R is the square root of R squared. That makes sense, right? But if you just state Well, since r is the square root of r squared, sure, r squared was 0.936, and you take the square root of 0.936. Of course, I turned off my calculator. 0.936 square root. You can get your correlation coefficient, which is 0.97, right? But here's the problem. What do we lose if we do it that way? We lose the idea, is it negative or positive? So if you do it the quick way, number one, you have to make sure you did the r squared correct. And number two, you've got to take a minute and now look at your data, look at your regression equation and say, hey, wait a minute, it should be negative. The other way to do it is to use the formula, and the formula, of course, is the xy divided by the square root, which you can do that as well. And you'll see you'll get the same answer. So we'll do it this way real quick. But what we don't lose here is our negative. Our negative is actually in there. So S of xy was, it's up top, negative 862.2. And then XX again was 30.9 times what? That's a YY, hold on. Yeah, that's YY. My X, I'm sorry, my X's and Y's look all the same when I'm doing this. 25,681.6. Or I drew my X's and Y's the same. That's not good. This one was Y. So you can go through that just to double check yourself, but you should get the negative 0.97 or close to it. Yeah, you get the exact same thing. So you can certainly do it the quick way once you have R squared, but just be careful because you've got to then pay attention whether you should make it negative or positive. Or you could be going through problems in math lab. Now, what math lab's going to do is they're going to give you like some of these variables and then ask you to find other ones. So hopefully, a lot of it will be given to you. So this tells us, forget the regression equation, it doesn't tell us anything about that. What it tells us is that X and Y themselves, the variables themselves, this would be considered a strong negative correlation. So that's how you would interpret that. You interpret it as the age of a car is strongly negatively correlated to the price of a car. I would say anything that is above positive 0.7 or below negative 0.7 is strong. Anything between like around 0.5, maybe down to like 0.3 up to 0.7 is just a correlation. And then anything closer to 0 is a very weak correlation. And if it comes out to 0 itself, it is no correlation. So that's kind of how you want to interpret those numbers. So this kind of takes you through one complete problem. That would be multiple parts, so you don't have to keep doing all the calculations over again. That covers basically everything in chapter 14.
On an exam, would we be given, say, a problem like this, but broken up into different sections, or would we be given multiple problems like this that are fully through?
Now, I like to give you one problem, kind of like I did on the last test, like here's the data. And then what I would do is probably have you find these calculations of the SXX, SXY, SYY first, and then I would multiple questions from that set of data. Now, if you do mess something up, I'm not going to take points off on the multiple parts. I will recalculate based on what you messed up to give you full credit. Yeah, I would only make you go through one of these ones. We'll actually, there would be another part to this that I'm not going to do right now because it's the chapter 15 work, and there's a hypothesis test that I would add to this so that, again, you already have the data worked out for you. You don't have to recalculate anything again. But like I said, this pretty much covers everything from chapter 14. And this does it with the Corvette data, which you can pull. You can also play around in StatCrunch. Do you guys want me to show you that on the screen?
Yes, please. I was actually just going to ask that because sometimes Math Lab asks.
I understand. I got to flip my computer the other way if I'm not, because it's hard for me to open. So let me see if I can I should be able to do this. If things go wonky, just give me a second. I think I can move this to the side. Yeah, there we go. All right. So I'm just going to show you generally how to use the StatCrunch because you'll be able to open data into StatCrunch and do different things with it. But when you go into StatCrunch, so what I did is I took a data set from books. So I'm going to take the data set that we were working in. Data set from textbook. All right. When you click data set from textbook, which you won't have to do, your data from MathLab will automatically open into StatCrunch. I think this is the data set I was working with. Let me see when it opens. Yes. All right. So you open your data set and it goes into StatCrunch like this, right? Yeah, this is our data, age and price. There's a couple things that you're going to want to know how to do through the whole chapter in regression. So I'll go over a few things with you real quick. One of them is to actually look at a scatter plot. This is very helpful to just see a scatter plot of your data. So that's the one thing, and that would be under graph. Especially, I think you'll be given a lot of options, so you're going to want to open the data and look at a scatter plot real quick. So under graph, go to scatter plot. Your X variable is the age. Your Y is price. I don't think we have to hit anything else. You hit compute. And there's just a scatter plot. So yeah, when you look at that scatter plot, you would think to yourself, that looks like a regression because they all fit pretty closely around a line. So that's one thing. Another thing is just to go ahead and do the regression. So you go to stat, you go to regression. We are only doing simple linear regression, and that just means we're looking at one characteristic, the age of a car, okay? Normally in multiple linear regression, we'd have a whole bunch of other characteristics like how often it's driven and that kind of stuff, but we're only doing one thing, simple linear. Let's do our X variable, age. Let's do our price. As you move into chapter 15, these two things will make sense to you. Not the intercept, we're not doing the intercept, but we are doing slope. And we'll get to that. We'll go over that one next week. I'm not going to do that one right now. Some other things that is nice is the graph with the fitted line plot. That's a good thing to kind of click on. And let's hit compute and we'll see what kind of information we're given. I want to look at the graph first, because there's the graph that we made and there's our fitted line. Okay, so that's one thing you can say. And let's see what kind of information it'll give you. It gives you right there, third line down. Does everybody see that? It'll give you that regression equation, but it's going to give you in the context of the problem. It's not going to have y and x, but they're the exact numbers we got, right? The 456 minus the 27.9. It gives you the correlation coefficient, the negative 0.967. It doesn't call it coefficient determination. It calls it just the R square, the 0.93. Don't worry about the estimated standard error. That's pretty much the information that you will be able to get. If we were doing a slope hypothesis test, you will get that t-test statistic and p-value, but again, we'll do that next week. And don't worry about the analysis of variance table. You don't need to go through that one. So that's the information that you can get from StatCrunch as you're working out problems in MATLAB. You can get the equation, you can get the correlation coefficient, you can get the R square, and of course you can get the scatter plot with the fitted line in it, okay? What we did was all the kind of formulas to get to this point. Yeah, I don't think there's anything else that's useful. I think the things you don't, like I said, you don't have to do the scatter plot, because if you go into regression, simple linear, and when you're selecting your variables, make sure you choose the fitted line plot. Oh, so here's something else, just to give you a kind of a, let's do one more, because there's something else for chapter 15. So in chapter 15, there's another plot that we're going to do. Let me see if our StatCrunch gives you a good version of it. Yeah. Okay. So yeah, did everybody see where I chose also? So this is going to come up in chapter 15. Regression, simple linear. Pick your variables. And choose fitted line, and also choose residuals. So residuals are something we're going to do in chapter 15 to let us know if our data is normal. And again, I'll go over that next week, but it's good for you to kind of see now where the graph is. And the, oops, here's the residual graph. Yeah, so this is a residual graph, and it's a graph of the errors, and it, sorry, it basically takes each point and says how far away it is, how far the, so think of it when we did the chi-square, how far away the actual data point is from the predicted data point of the regression line, and then it graphs it along a zero and plots a point. So this is another graph that could come in handy when you get into chapter 15, because you are going to have to learn how to do a residual plot. It's actually really easy. It's just subtracting two numbers and plotting them along a zero, but this way you know where it is now in StatCrunch. And the idea behind the residual is if there's a pretty even number below and above, like it kind of goes back and forth like this one does, then you could say that your data is normal enough that you can continue with a regression equation. That's another one that could come in handy. So that's everything you can get out of StatCrunch with any data that you pull into it. So any other, sorry, questions? That kind of, again, takes you through an entire thing, which gives you a lot of information to finish up with chapter 14. I will try to get a little video. I may not be able to get it up till tomorrow, though, that specifically goes over the coefficient of determination. I got to do one that specifically goes over the correlation coefficient. They'll be short because they're just 2 quick calculations. And then on Saturday, I'll get up the chapter 15 videos, which bring us back to hypothesis testing. Yeah, next week is just taking what we can from, basically it uses correlation and it uses the slope, and we run a hypothesis test using just a t-table, so you don't even have to learn another table this time. So any other questions that you want to go over now? Jess?
I have a quick question just about my math lab, my stat lab. That same information that you gave us at the beginning of the problem, are they going to provide us with that same information?
So they're going to have different information and different problems. I don't know if I have, do I have it open? Oh, I do have it open. Let me take a look. Let me just look through some and see what they have. So let me look at some chapter 14 stuff here. Assignments. Yeah, sometimes they'll go ahead and give you like the SSR and the SSE. Like they're going to give you, that's why it's important. I wanted to take you through all different parts of those formulas because you just don't know what you're going to be given.
But on the exam, you are going to provide us with those.
Yeah, on the exam, I'm going to do it just like we just did that last problem. Definitely just like we did that last problem. This is probably just, yeah, that's best fit. So there's a video on best fit. Yeah, these are just some quick things like, would you put a correlation around that? No. I'm trying to get to, that's another best fit. Do they do one with the, yeah. So this must be one where they give you a set of data. They expect you to pull this into StatCrunch though. Clearly, it's a really big set of data. So whatever follow-up questions they're going to ask. So here, let's take a look. We'll take a look at this one. Can y'all see it?
Yeah.
Yeah, you'll get different. You'll get different numbers, but you clearly have to take this data and open it in StatCrunch. And the first thing it looks like we need to do is a scatter plot. We'll just do a quick scatter plot, right? So X, oops. X is, I think, the first one, yeah. Y is the second one. Just compute. Okay, so there it is. It's relatively going up. So we got to pick the one that fits that the best. I'm assuming it's this one, right? Does that look good?
Yeah.
Yeah, that's good. I just want to see what kind of, so yes, they're deciding there is a linear pattern to the data, so it is appropriate to carry out linear regression. Yes, that seems to be the one that I would pick. Yes, have they give you more? No. Oh no, there is more. Parts remaining. Oh, determine, interpret the regression. Oh, so see this problem? They want you to use StatCrunch. You just have to open the data back up in StatCrunch and come up with the linear regression equation. So they're not asking you to do any of the computations. They're asking you to open it in StatCrunch, and that's where you have to go through clicking the regression, simple linear. Okay. So for that problem, you don't. And my guess is for the, let me get rid of this one. Having a hard time because I can't see everything. There we go. So let me close that one. Close that. And then if we do 14.3, which is the coefficient of determination, I think they give you various pieces of data. Yeah, there's only a couple of questions. Yeah, it's fine. Leave. Yeah, so compute the 3 sums of squares. So this one, you do have to do it the way we did it for this particular problem. What they're not giving you, what I give you, is the sum of the x's, the sum of the y's, the sum of the x squares, the sum of the y squares. But they're also only giving you 3 pieces of data, so you can easily get the sum of the x's, the sum of the y's. Do you understand what I mean?
Yeah.
Yeah, and then with that data, you can go ahead and find everything else. The other thing you can also attempt to do when you look at your formula sheet directly for SST is you can use that defining formula if you need to, and do it individually. So they're going to give you a really small set of data. I got to plug my computer in, it's going to die on me. They're going to give you a really small set of data to work with, so the calculations aren't going to be that daunting. And you can do it the way we just did it by getting, you just have to calculate summation of x squared yourself, which really shouldn't only take you a minute to do. Let me look at the next one and see what else they give you. Yeah, so see here, they're doing it just like I did it. They give you all these values. So that's going to be calculated just like they give you everything. They even set up the formula for you. So that's going to be a lot like the one we just did. And this is probably one where you have to pull everything in step crunch. So I think you should have no problem if you follow what we just did doing these problems. It should be pretty simple. Okay. Any other questions?
No, but